Okay, here's the plan. You, me, all of physics, in 10 minutes. Let's do this. First came these guys, and many made monumental discoveries, while others were just plain nuts and made up a bunch of pseudoscientific BS. Just like this video. We'll skip them. And these guys were important as well, but I don't really know anything about them, so we'll skip them too. Physics begins with Sir Isaac Newton, who may or may not have been struck on the head by a blunt red object. He figured out that if you push or pull on things, they move. Since we live in 3 dimensions, you put little arrows on all these symbols. If more than one thing pushed or pulled, you draw arrows in their respective directions and add them together to find the total amount of push. Eventually some other people would come along and make this unnecessarily complicated. Anyway, back to Newton. He figured out this pulling thing also worked between the Earth and the Sun, and that if you had an inverse square law describing the amount of pull, you could explain the orbits that astronomers had been discovering. He definitely figured this out by himself. He didn't rip off anyone else's ideas. To quantify his theory of motion, Newton invents calculus, but just despite high school students, they're only taught the math and not what it's actually used for. This guy also develops calculus, but he does it better, but Newton gets most of the credit because he's Newton. And that does it, folks. We're done. We know everything about how the world works. Just draw force vectors and do calculus. I can solve the two-body problem of a planet orbiting a star. If you gave me a few weeks, a computer, lots of caffeine, I might be able to solve a 3-body problem. What do you mean, you have 1 mole? I can't solve a trillion bodies. Turns out there are not enough trees in the world to perform this kind of calculation. Luckily for us, this fantastic man sporting a fantastic beard figured out that calculating the motion of a trillion particles is stupid. Instead, just focus on a few important properties, say like pressure and volume, and ignore the remaining trillion. This idea is known as statistics, and linked up with work pioneered by this fine gentleman. Work, get it? Work on heat and temperature and entropy. And thus was born the marriage of statistical mechanics and thermodynamics, a marriage stronger and healthier than most relationships between couples today. And carpal tunnel for pretty much everyone studying this nonsense. I mean, seriously, look at this. Look at this. Look at this. Luckily, we'll never use this stuff. I mean, how important could it be? Okay, ladies and gentlemen, we finally understand everything. Everything. Whoa. Who are you? James Clerk Maxwell. And that's a fantastic beard. You say you can explain electricity and magnetism? That's right. This guy wrote down a bunch of equations that a bunch of other people discovered. Allow me to explain the equations. Charged objects create electric fields. Moving charges create magnetic fields. Changing electric and magnetic fields generate each other. A charge in an electromagnetic field feels a force. Light is just an electromagnetic wave. And just like thermodynamics will destroy your wrist with partials, electromagnetism will destroy your mind with vectors. And not only will it ruin your mind, it will also ruin your understanding of physics. You see, physicists at the time knew, wrongly, that light was a wave. But just like seismic waves travel through the earth, and sound waves travel through the air, light must travel through something. They call this medium the ether. The A is silent, and Michelson and Morley wanted to know how fast the earth was moving through this ether. So they set up a device that could detect incredibly small changes in the speed of light. If the earth is flying through the ether, then light moving in the same direction will move at a different speed than light moving at a 90-degree angle. We measure this difference and find the speed of the earth. Voila! Ingenious experiment, and of course, it didn't work. But this is because the physics is wrong, not the experiment. All measurements reported the same speed c. Light always travels at the same velocity, no matter how fast the observer is moving. So our ideas regarding vector addition are wrong. Oh, and Mr. Newton, we're double-checking the orbit of Mercury with our latest precise tools, Mr. Newton, and I'm afraid your theory isn't right. The solution to all our woes is provided by this mysterious violinist. He figured out that if you change the way you added velocities, you could fix the problems found in the Michelson-Morley experiment with vector addition. Seriously, check this out. Instead of adding like normal, divide by this additional factor, 1 plus the product of the two velocities divided by the speed of light squared. If you divide by this additional factor, the Michelson-Morley experiment works out, because when you add c, the speed of light, to any velocity, you end up with c, just as observed. This special type of addition of velocities really implies some very strange things when you go at speeds close to the speed of light, for example, the dilation of time or the contraction of space. This is called special relativity. But this still doesn't explain the errors in the orbit of Mercury. So the same gentleman decided that not only did velocity affect time and space, but so did acceleration, or gravity. You see, we think that the Earth is going around the Sun in a circle, but actually, it's going around in a straight line. It's just that time and space are curved, so a straight line is actually a circle. And now, if you develop a theory of gravity based on this idea of shortest possible distance and curvature of space and time, the orbit of Mercury actually works out. It agrees fantastic with the new observations. These equations that Einstein created, oh, come on, he's Einstein, you know that. These equations that Einstein wrote down are so complicated that only a computer can solve them. So, of course, this man solves them without a computer for a black hole. He does it while being shot at, too. And, of course, all this relativity stuff is completely useless. I mean, just ask Al-Qaeda. Alright, Sir Isaac, it's been a long and arduous journey, but finally, we're done. We've reconciled Oh, not you again. What is it this time? What do you mean our current theory says that atoms should implode? And make up your mind, Light. Are you a wave or a particle? And so once more into the fray, we again find a problem with classical mechanics. This time not at high velocities, but on the small scale. We're talking nanometer scale, like the size of an atom. Here's Bohr's model of an atom. An electron goes around a nucleus in an orbit, bound by the electrostatic charge. But the problem is that if an electron is orbiting the nucleus, it should radiate energy in the form of light. So say Maxwell's equations. This means that the orbit will shrink until it finally collapses into the nucleus. And since humanity is still around and the world is alive and well, we know that this is wrong. There's also the issue of light. Is it a wave or a particle? Light was thought to be a wave because of interference effects. The highs and the lows of one wave add to the highs and the lows of another wave, creating an interference effect of alternating bright and dark regions. This double-slit experiment shows that light's a wave. But no, because Einstein proved that light is actually made of particles, or quanta, called photons. He did this with his famous photoelectric effect experiment. Light of a low enough frequency doesn't have enough energy to kick electrons out of a metal, no matter how intense the beam. This is because each individual photon isn't strong enough to kick the electron out. And so, light is made of quanta. What about electrons? Those are definitely particles, but astonishingly, they can also interfere. The reconciliation of this duality was provided by these fine gentlemen, who created a rock band called quantum mechanics. Photons and electrons are particles. End of story. The reason they can interfere like waves is because particles aren't points. They exist as a sort of probability cloud. An electron might be here, or there, with a certain probability assigned to each location. An electron isn't orbiting a nucleus, it lives in a cloud around the nucleus, with the probability concentrated around where the orbit should be. It's this probability that causes the interference we see in the double-slit experiment. Schrödinger, after ritually sacrificing his cats, developed his famous golden equation. At least, I think he killed his cat. Can't be certain. Snubbull's possible sacrifice wasn't in vain. Now we can finally explain this thing. Tell me how many sleepless nights you suffered, wondering why on earth the periodic table looks so weird. Why are there 2 rows at the bottom? Why are there only 2 columns at the top? Why does neon glow red? Why does California have an element and not Wyoming? And why are aliens obsessed with blackjack? Well, you have your answers here, folks. Quantum mechanics explains atomic structure extremely well. Okay, now we're done. We know everything there is to know, right? Well, of course not. This man is a professional bongo drum player, and he does physics as a hobby. He's going to ruin your day. If you try to combine quantum mechanics and special relativity, and try to solve the simplest possible problem, you get this as your answer. Infinity minus infinity. It's the correct answer. But there's a minor issue. We have no idea what it actually is. So to solve this issue, the rock band made a comeback called quantum field theory. They figured out that if you drew a bunch of diagrams made of a bunch of squiggles and lines, performed some extremely dubious mathematical tricks, and stood naked under the full moon while chanting the Kama Sutra, you get the right answer. Now, every mathematician worth a lick will be bursting a hemorrhoid at this. But in the words of the professional bongo drum player, mathematicians are losers. So abstract this nonsense, you posh axiom-snorting snobs. Who needs mathematical rigor when you have this bad boy? So we've created quantum electrodynamics, QED, which combine electromagnetism with quantum mechanics. But there's more. We've got neutrinos and the weak interaction, so we created a god particle called the Higgs and generalized QED into the electroweak theory. But then we couldn't include the nucleus in our theory, so we added quarks and gluons and made QCD, quantum chromodynamics. So now everything in the world is described by a giant theory. Wait, we're not done? Nope, we got the standard model, even bigger. And what do you mean gravity doesn't work with this theory? And what do you mean we might discover more particles if we build colliders with higher energy? What, you're saying we should burn another couple billion on an even bigger collider? I'm game. Come on, Uncle Sam, we can't have the Europeans have the biggest one. I mean, I'm sure this will be useful eventually, right? And you guessed it, we're still not done. We need to solve the quantum problem with a trillion objects. This is the realm of condensed matter physics, which is slang for everything in physics that doesn't involve particle accelerators. It turns out this problem is far from hopeless, quite the contrary in fact. Crystals, extremely prolific in nature, despite having huge numbers of atoms and electrons, are actually tractable because of their symmetry. With only a little pain, we get the band theory of insulators and conductors, which also explains these weird things called semiconductors. They turned out to be pretty useful. Then this guy found out some really cold metal started levitating magnets and conducted electricity pretty well, but no one could explain it. It took 40 years until a third rock band, the Revival, came up with the BCS theory of superconductivity, and blew our minds. As for other uses of condensed matter, everything in the world, your computer, your television screens, the metal in your car, the drywall in your home, was engineered with the help of condensed matter physicists. Worship us, and please give us a raise. Okay, we're finally done. We've gone through all of physics and there isn't anything else. Nothing at all. Whoa. I just had some sort of weird hallucination there. Well, whatever. I'm sure it's just my imagination.